Welcome to the third session of Bruker Elikona video series. Today with the topic product portfolio. I will go through here in our metrology launch and I will explain the differences between our product lines. You know already from the second session that all products are based on the focus variation technology. And at that time, Franz, our head of R&D, explained very well what the technology is about. Also today, he will help me during the session to explain you the differences and his ideas during this product development phase. The agenda will be, we will start with the Edgemaster series, followed by SL, then Cobot and sensor-based systems, G5+, Micro CMM, and the portable RL unit. So Franz is already waiting for me in the first measurement room, so let us move there and start our third session. Welcome to the first product presentation. I am standing next to Franz, our head of R&D.
Hello.
And next to two units with a different configuration. The Edgemaster series is a dedicated product for the cutting tool industry. Franz, what was the idea behind the development? What did your team and you focus on? What were the requirements of the customers?
First of all, the ease of use. This is a typical part, an insert, and I want to show you how easy it is to use this type of equipment. You put the sample in, you focus on the surface with the coarse drive, and then you press a button. Secondly, the small footprint. This is perfectly suited for shop floor use. Third, the full automatic operation. So the generation of the 3D data and the evaluation of it is done in one step, full automatic. Here you see the result of the measurement. And fourth, the results are not only shown on the display, but also fully automatically transferred into the IT infrastructure of the company.
Okay, but here we have now a different configuration. We have here a manual table and an automated motorized table. So why did you decide on this kind of an upgrade of the system?
Okay. The left one is the normal Edgemaster with manual XY stage, perfectly suited for one sample. The right one is the Edgemaster X with a motorized XY stage, where you can do multiple parts with one press of a button or multiple edges on one sample with one press of a button.
Our customer may ask, why didn't you change objective, or why did you not adjust the objective during the demonstration?
For edge preparation measurement, you don't need to change the objective. One objective is fine. No problem. But the Edgemaster and the Edgemaster X can do much more. For example, it can measure the roughness on the flute, for example, which is very important. And therefore you change the objective to a higher magnification one.
I think this is fantastic to have one system for two applications. We are able to measure the radius, we are able to measure the roughness in the flute, what is a very important parameter for the chip flow in the cutting process. Is there any other benefits that the system can bring?
There are two more benefits. First one is the edge quality. So for edge preparation, the edge must fulfill a specific quality, and the edge quality module can quantify these very important values. And lastly, the wear. When you develop a tool, the wear must be below a specific limit. And there is software built in to quantify the 3D data set in relation to standardized wear parameters.
So ladies and gentlemen, let me summarize. I'm next to the Edgemaster series. It's a dedicated product for the cutting tool industry, but also for the users of this kind of tools. And these two high accurate systems makes us to the world leader in this industry.
Yeah.
But after talking about a system that is really for one industry, let us move now to the Infinite Focus SL, that is a much more flexible system for production and research.
Let's go.
The Infinite Focus SL, a very interesting and flexible system for academic sector or industry, like medical, automotive, forensic, aerospace, cutting tool, or even electronics. So, Franz, we are focusing here on form and roughness. Can you explain us a little bit about the hardware setup of the instrument?
Yes, I can. Let's start from the top. Here on the top of this instrument we have a sensor that uses focus variation as technology. Therefore it has got a motorized Z-axis for scanning, and it uses patented ring light illumination. We also have a coarse drive to easily focus on the sample. On the bottom of the instrument we have a motorized XY stage, and we have an option for a motorized 4th axis that allow us to rotate the sample and get 360-degree measurements.
This hardware setup already ensures to solve a lot of applications. But what is about the objective?
So there are different objectives in our product portfolio. The lowest magnification is the 2x, where you have a field of view of 10 × 10 millimeters. The highest magnification is the 50x objective, and with this you can get 3D data with a vertical resolution of 20 nanometer.
What is about the software of the instrument? Hardware very flexible. Is the software also, do you also have available software to solve a lot of applications?
So there are a lot of different software modules built into this machine. One is surface roughness. So there are modules for profile roughness and surface texture measurement according to the existing standards built in. There are modules built in to measure the contour and to measure form, specially built for real 3D. Our technology to get 360-degree measurements. As you can see here on the screen, this is a gear, a measurement of a gear. These are the main software modules. There are additional software modules like the automation manager, where you can easily automate tasks yourself.
Mm-hmm. And the customer asks themselves most likely, what is about the environment? Do you need to be in a dedicated measurement room as we are now here in the metrology lounge, or is it also not really sensitive to vibrations, to environment light? What can you tell us about this?
So since the instrument is very small and very fast, the temperature is not a big issue here. Additionally, we have built in a passive vibration isolation system here in the ground plate of this instrument to isolate vibrations from the ground floor or from the table.
So ladies and gentlemen, let me summarize the Infinite Focus SL. A very flexible system that focuses on form and roughness, with even the possibility of a 4th axis to generate real 3D datasets. In terms of hardware and software, a really accurate and good package for you. Now let us move forward to the third product that we are presenting in this video series. And it's already on the back side, it's our cobot system, and we will have a look there now. Hey buddy, say hello to the customers. We're in the middle of the next product presentation, the cobot systems. This kind of product is dedicated for bigger parts, and with the focus variation sensor in the cobot, we were able to enter the industrial production metrology market. There were quite a lot of requests for the product. So what was your aim in the development, Franz?
So priority one was to have an instrument that can handle larger parts and to measure on these larger parts with an optical sensor that delivers millions of 3D points. Second priority was to have an instrument that is easy to use and not complex.
Can you first tell us a little bit about the hardware setup of the system?
Of course I can. So what we have here is a very stable basement where we have all the electronics and power supply for the equipment on top. There's also the monitor and the keyboard built in here, and on top we have the robot that is a collaborative robot, and on the robot we have the sensor that uses focus variation, and we have some handlebars to move the sensor around. Connected is the sensor with the basement via a high flex cable to allow operation without any problems.
Franz, the handlebar, I like this very much. Can you show us how easy it is to teach in the system?
Yeah, it's very easy. So you can grab the handles, press a button, and then you can move the robot to the measurement position. Then there is another button where you can switch to the focusing help. The ring light is switched off, the laser is switched on, and you can easily see where you're measuring at the moment. With the joystick, you can adjust the position in X, Y, and Z direction to exactly focus on the spot of interest. When everything is done, you acknowledge with a button, and then this position is stored in the sequence. Another way of operation is to use a CAD/CAM software. In this program, you click in the CAD model on the desired measurement position and store this in the sequence. When everything is done, you can store the program, and an operator can simply use this later on after putting the sample on the table and press a button to store the whole sequence. At the moment here you can see how the robot moves to different locations, measures them, and then continues with other positions on the sample.
Here we are next to the compact cobot, our basis configuration of the cobot series. But it's very easy to upgrade the system with a horizontal motorized axis or even with a vertical motorized axis.
There are even more options, so this table can be configured to be larger or smaller, and different mounting positions here. There are also options for different safety depending on the location where it is used.
Ladies and gentlemen, let me summarize the main features of the product. It's a 7-axis system. Franz explained it. It's very easy to use. It's dedicated for big parts where you need features in high resolution. So if you're interested to have this next level of production metrology on your shop floor, you're really welcome to contact us. We are next to the 5th generation of the Infinite Focus product line, the G5 Plus. A mature product that should not be missing in any QA lab, not in any research facility. It's really the Swiss Army knife in optical 3D metrology.
So this optical instrument includes focus variation and vertical focus probing that allows measurement of vertical walls and holes, and this technology gives results that are material independent.
The instrument is a champion in 3 aspects. First, it was the first product developed by Bruker Lekona. It was the first product that had a focus variation in the optical market, and it was also the first instrument that featured our real 3D technology. So Franz, let us focus on the hardware. Can you explain us a little bit about the setup here?
Yeah, okay. So on the top of the instrument you have the sensor. The sensor includes the Z-axis with 100 mm of travel and has got a built-in linear encoder. The Z-axis moves the optic up and down for scanning. And the optics includes 2 types of illumination. First one is the coaxial illumination, and the second one is the ring light illumination. The ring light you can see here can be easily detached and attached again to different objective lenses. Each objective lens is mounted on the motorized nosepiece, and the lenses feature a range from 2.5x magnification down to 100x magnification. And with the 100x objective, you can get a 3D data set with 10 nanometer resolution. On the bottom of the instrument, you can see a motorized XY stage with 200 mm of travel. Then there is an optional motorized rotation and tilt unit with different options for clamping of the sample.
Franz, what could be the best application for this kind of a hardware setup?
So the best application for this, I think, is microgeometry measurement, where you have roughness and microform, microcontour all in one small area where you use all the 5 axes of the instrument and where you need millions of 3D points. Then this equipment is best.
Franz, but how is about the software modules? Do we have everything available to solve these kind of measurements and applications?
Of course we have. So we have dedicated software modules for roughness, one for profile, one for surface texture. We have something for contour, for form, and we also have something for GD&D measurements. There's also a module for cutting edge measurement. And all these modules and many more work together and can be automized. So when a worker goes to the machine, puts in the sample, press a button, then the instrument makes the sequence of measurement and then shows the result and prints out the report. So it is the Swiss Army knife of metrology.
Yes, perfect. Ladies and gentlemen, you're welcome to contact us, our sales team. They're consultants in optical 3D metrology. They're able to support you with your application. They're able to support you with the best possible configuration for this application so that you are perfectly armed for your challenges in metrology. And now let us move to the next room and to our flagship, the Micro CMM. Well established and appreciated by our customers, the flagship in our product portfolio, a benchmark in optical 3D metrology. It's the first optical aerial-based coordinate measurement machine, our Micro CMM. Next to me, the 3-axis device, and on the other side the extension with the real 3D unit to 5 axis. Franz, I think the development of this instrument was quite challenging.
Yes.
What was your goal with the Micro CMM?
I can tell you. The goal was to have an instrument with high accuracy. So with this setup, we reach accuracy of 0.8 plus L over 600. Secondly, we want to have an instrument with focus variation that can measure smooth samples, like lenses, glass, wafers, or highly polished parts. And last but not least, the instrument should be able to be used in the shop floor.
But wait, Franz, why is it now more accurate? How is it possible that you suddenly are able to measure these high polished, smooth surfaces? And why is it possible to put it on the shop floor?
I'll tell you. So this instrument uses granite as a base. The drivetrain is a linear motor and is air bearing, so very accurate. And the linear encoders built in are from Ceradur, so which means that they do not expand with temperature changes. And they are from Heidenhain, so best in class. The optics that were built in here uses the Smart Flash Generation 2 feature. This means that the illumination can be varied over time and over the position in field of view, and therefore we get all the small details of the sample even if it's very smooth. And we use temperature sensors, and since we use this very rigid setup, the system can also be used in shop floor with very good accuracy.
Okay, that's great. It looks a little bit sophisticated, and is it very complex to use as well?
It's not. Other instruments from Elikona use a different software concept, and also many other instruments use a different software concept where the operator has to specify how to get the 3D data and how to work with this 3D data to get the result. So you need to be an expert. With this type of equipment, we introduce a different and new software concept where the operator loads a CAD file with the BMI information, then it clicks on the BMI information and selects Verify. And then the software automatically knows where and how to measure the 3D data. The software automatically knows what to do with the 3D data, fit in a cylinder or calculate the flatness or whatever. And in between there is also a step that makes a collision check so that there is no collision when this automated process is done.
Okay, Franz, you convinced me in terms of hardware, in terms of software. For the customers, let us summarize. It's really a high accurate device that is really possible to measure very smooth surfaces, and it's a total new user experience. And now let us move to the next product of this Bruker Alicona video series, to the Infinite Focus Portable G2. Outside the metrology launch, directly in front of the Bruker Alicona headquarters in Austria, we have another product now to present. Franz, what is in your trunk here?
So we have here the portable. There's a portable device using focus variation. And focus variation is the right technology for such devices because it varies the focus over a specific length, over a specific scanning length. And this is larger than with confocal or white light, and therefore it's more robust in relation to vibrations. So the instrument has got a handle over there where I can grab the instrument and put it where I want to measure. In this case, we are measuring the racetrack. And the racetrack measurement is important for Formula One industry. They're measuring the surface texture and then they decide on their tire strategy. The instrument itself consists of the sensor with the ring light illumination and the motorized XY stage. This means that we can measure up to 50 times 50 millimeters on the surface.
We developed this product because we got a lot of requests from different industries: car manufacturers, tire manufacturers, aerospace industry, and even paper and print industry. And Franz proved very well today that our technology is really much suitable for this kind of portable devices. And now let's go back to the metrology launch and sum up this session.
So I hope you got a good overview over our product portfolio. All of our products are based on focus variation and therefore they are very robust and very versatile.
Franz, thank you very much for your support in this session, and I would also already like to invite you to the fourth session of the Bruker Alicona video series, to the cobot systems.